Hey everyone, my name is Ronak back with another video, and this is 33rd video in the Getting Started with the Machine Learning playlist. And in this video you are going to learn the Gini impurity in the decision tree. So let us get started. So in the last tutorial we have covered the entropy and information gain, which were one of the hyperparameters associated with the decision trees. So these are present in the criterion section. So by default the tree always works with the criterion as Gini. So this Gini is also one of the parameters, hyperparameter, that you can tune accordingly in order to get the best performance out of the tree. So what is Gini impurity? So Gini is a measure of purity, alright. Just like the entropy, it is same as entropy, but there are some minute changes, alright. So the goal to be achieved is always going to be the same. For decision tree, it will tell us where to split, and it is less computationally expensive and preferable than entropy. Decision trees work pretty good with the Gini impurity. Now you will come to know that what I really mean by this when you will actually have a look at the formula. So this is the formula of it. The formula, obviously, just looking at the formula you would be able to identify a lot of things, but with an example it would be quite easy. But stating the obvious, so the formula is 1 minus summation over probability squared of all values, alright. So you will actually come to know the way we calculate it, and it is much more easy. Now what do you mean by being computationally expensive? Why entropy is computationally expensive? The reason is it has logarithmic values in it. Since the log is involved, it is always going to be computationally expensive as compared to, let's say, Gini. Gini on the other hand gives you probabilities or the bit values finally that you have, which are around 0.5. They are not going to exceed that. So it is computationally less expensive as compared to the entropy. That is the reason people prefer Gini. So this is the dataset that we have been working since the last two tutorials, but let me just brush up some things. If you are new to this video, this is going to be a new dataset for you. So this is the most commonly used dataset in the area in order to learn the machine learning concepts. Naive Bayes usually uses this example, but we are using it for calculating the Gini with decision tree. The dataset is about playing golf. So whether you are going to play golf or not. So this is a binary classification problem. In that you have 4 attributes or 4 features you may as call. So those are outlook, temperature, humidity and windy. So these factors actually decide the dependent variable that is playing the golf, which is a binary classification problem. So we will actually consider the Gini index of the playing golf in the first place. So now you will actually come to know how we can go and work with this formula. So this is the way we do it. So in the situation, there is always going to be the play golf column, and we are going to work according to this. Actually we are going to hold this label class and then work with the attributes accordingly. So Gini we get with the play golf is 1 minus the formula. So now we have to calculate the Gini for 9,5. So what is 9,5? We have 5 no values and 9 yes values in our data set. So if you don't have any idea about what the criterion is or the decision tree, you can check the earlier tutorials, alright. So those are very obvious and very easy to understand. Anyway, Gini 9,5. So 9 is basically yes, the values of the yes that I have. You can count it in the play golf class. Similarly, you have 5 no values. Later on, how you calculate the Gini? So Gini is 1 minus summation over. So since there is summation, we have to calculate it for yes and no. So P of I. So how do I get the probability? So I get the probability. So I have 9 yes out of 14. So 9 by 14 squared. Okay, we square the things. So this is quite less computationally expensive, as I said, with respect to, let's say, the entropy, because in this you have no logarithmic value. Similarly, you add, so since we are carry forwarding out the summation, and then we say 5 by 14 the whole square. Why 5 by 14? So 5 is for the no values that I have. So those are total values are 14, out of which no are 5. So that is the way I get the probability. If you calculate it further, we are going to get 0.46. Alright, so it is something 0.459. Alright, I calculated all this manually. I just rounded it up to a certain extent. Now we are going to consider the first attribute, outlook. So all of these attributes are finally going to tell you from which precedence you are going to make the splits. I'll come to that, but now we are going to consider the outlook with respect to playing golf. So you are going to play golf with respect to outlook, where you are going to find the Gini impurity of it. I would say the tree with the least impurity is always going to be the root node. Construction I'll tell you, don't worry. So this is the way we do it. So Gini, so we are actually going to take all the unique tuples from the outlook, which are sunny, overcast and rainy, and we are going to multiply them with the Gini index of the occurrences. Alright, so if you check the outlook, the sunny has appeared for 5 times. You can see it over here, 1, 2, 3, 4 and 5, out of which 3 values are yes. Okay, so this is yes, this Sunny is also yes, and this Sunny is yes, and there are 2 no's where you have this Sunny as no and last one tuple is no. Similarly, you are going to then do a summation with respect to overcast where you have 4 values in total. Alright, out of which 4 are yes. So you have overcast over here, yes, overcast over here, which is yes, overcast, the second last and the third last, both are yes, and no values are 0. Then you are going to take it for rainy. So you have to identify the unique tuples and you have to check how do they interact with my playing all. So the number of the occurrences of the yes and no I have to calculate, and then of those yes and no I have to calculate the Gini impurity, and I'm going to multiply with the probability of the data. So it seems quite complicated, but it looks like this. So Gini for playing golf with respect to outlook is 5 by 14. Now out of 14 values, I have 5 Sunny values. That is why the occurrence of the probability, the occurrence of the Sunny in the entire table is 5 by 14 multiplied by 0.48. Now that is the Gini index of 3,2. Just like I calculated earlier. So the formula, the way it actually would work is 1 minus 3 by 5, since the probability of the occurrence that I have with respect to the entire value. So the way I get it is 3 by 5 the whole square plus 2 by 5 the whole square, and the value that I'm going to get is 0.48. Similarly, I'm going to proceed with overcast and similarly with the rainy, and even in the rainy I get the same values, and the outlook value that I get is 0.343. Now you are going to actually store this value. This is the Gini value, because we are going to compare all of the Gini values with each other and we are going to select the least value as the root node. Alright, that is the attribute we will start traversing our tree with. Similar goes for the temperature, where you have hot, mild and cool. You are going to check the hot occurrences. So we have 4 hot values where are 2 yes, 2 no. In the mild section we have 4 yes, 2 no. So we have total 6 mild values, and similarly we do it for cool where we have 4 values out of which 3 are yes, 1 is no. And we are going to find Gini indexes for all of those. I have calculated all of this manually. You can please do it. I would actually suggest you to do it. Just use a calculator and do it. Alright. So the way the hot works is 4 occurrences out of the entire 14 multiplied by 0.5. So the way the 0.5 comes is because the Gini of these similar numbers is always going to be 0.5, which is the highest probability or a bit occurrence of it, and for the least, which is when the 0 is involved, it is going to come as 0. So that 0 says that you have reached the leaf node and it is the least impure section of it. Similarly, you are going to move on with the 6 by 14 where I have 6 mild values, out of which the occurrences, the probability that I get is 6 by 14 into 0.444445. So that actually comes when you calculate the Gini index of 4,2. So the way it goes is 1 minus 4 by 6 the whole square plus 2 by 6 the whole square. And this is the value that I get. Similarly, I do it for the cool and I get the value. So this is the temperature. So playing golf with respect to the temperature Gini index, this is 0.444. This is the value. Similarly, I do it for the humidity. Alright. So this humidity actually gives you the Gini index, which is 0.3675. Okay, I have calculated it manually. You can try it. And the calculator that I use is the Casio FX991ES Plus. Alright, you can use any calculator you want. Similarly, I'll also do it for windy, where I have only true and false. I have to check the occurrences. I'll have to check the yes and no's that I get, and I have to calculate the Gini index of it. So the Gini that I get is 0.428. Now, what am I supposed to do with all of these Gini values? So I'll tell you what you can do with all of these values of the Gini that you have. So these are the occurrences, the values of the Gini that I have with me. What I'll do is, in order to select the feature, now I have 4 features which are outlook, temperature, humidity and windy. The thing that I'll be doing is I have to construct a tree. I have to traverse through it. So the root node is going to be always the value which is the least impure, which is outlook. Then the second least value is humidity. Then we have windy, and finally we have temperature. That is the precedence order of constructing a tree. So outlook is always going to be the root node. Later on humidity is going to come. Then we look for windy and then the temperature. Since we have all of these values, now I will give you a walkthrough of the code, the implementation. And here we are. Alright, so I have already did this. So just import pandas, then a gold dataset.csv, you can find it. You will actually have this notebook, the dataset and the presentation in the GitHub link. Okay, you can find that link in the description box below. So this is the data, exactly the same data that we used in order to calculate things manually. I'm going to drop, so I'm actually preparing X with these 4 values. I'm preparing Y also with the label. I'm going to check the shape. Then I'm going to label encode those. Since label encoding is required in the X because these are all categorical variables, I have label encoded everything, and the way my data set looks is like this. Later on, what I'll do is I'll take decision tree, and here I'll say criterion is equal to Gini. Obviously, even if you don't specify, it is not going to matter because by default it is Gini. But just for showcasing purposes, I have shown you. Then I'm going to say X drop outlook, temperature, humidity, and windy. Since I don't require these because I am only relying on these: outlook, temperature, humidity, label encoded, and windy. Alright, so these are label encoded numerical values which I am going to require. Then I'm going to fit my model which says criterion is equal to Gini. Then I plot the tree. Definitely now this plotting is not very cool, so I actually went through an article. I'll show you. This article is about visualizing the trees. Alright, whenever you work with the trees, and this is by Michael Galernick. I hope the pronunciation is correct. Very great article on the towards data science. Okay, I have posted the link, you can check it. So Michael actually performed the computation with the iris dataset, and he actually gives you a lot of tactics with which you can visualize the trees. Alright, so I have used this code, alright, and modified it according to me. So this is the code, alright, where I use the matplotlib for visualization. Then I put figure and axes, and I give the DPI and everything, the size of the figure and everything, and then I plot the tree. Alright, so plot tree is basically available to you in the scikit itself. Okay, so it gives you a tree something like this, but we want something which is more clear and good looking. Alright, so then we fit it our model, the feature names, which are my X columns, and then my classes. So Y values. So Y values are basically yes and no. This is a binary classification problem, and then I say field is equal to true, and finally I save the figure, and this is the way the tree looks. Alright, this is my tree. So as you can see, the topmost root node is outlook, since the Gini index of it was the least. Alright, later on humidity, then windy, and finally we have the temperature. So this is the way the tree is going to be constructed using the attributes, and you will find this code in the description box like I said. So I hope you might have learned something or the other from this tutorial, and if you haven't subscribed to my YouTube channel, please do that and click on the bell icon so that you are not going to miss out any of the updates that I have on my channel. So thank you for watching. Goodbye.